Hello mate and welcome to Introduction to Ren'Py Part 4. Before I get started, a huge thank you to everybody for subscribing and hitting the notification icon. That really helps me out. And also a massive thank you to my members and patrons. Your names will be running up the screen at the end of the video. So let's jump into this. During this lesson, we're going to describe labels and call functions. We're going to describe the difference between call and jump. And we're going to demonstrate how jump can be used effectively. So what is a label? A label refers to the start of a block of code, and you can use as many labels as you like during your code. Labels are simply a flag that indicate where a block of code begins. At the end of each label, we will put a return statement in which tells Ren'Py when that block of code ends. Labels can be jumped to or called. Why do we need labels? Well, labels allow us to quickly navigate around our code. They allow us to break up the code and make it clearer where different functionality is included. It also gives us markers that we can move to within our code, for example, using call and jump statements. And as such, allow us to carry out repeated tasks without rewriting code over and over again. So what is a call? A call function is what allows us to place a flag at our current position within the code. It will then jump to the label which has been called. It then actions the code within the label that we've called. Once it reaches the return command, it returns to the position that it flagged. Calls can be nested inside other calls, meaning that you can call another function from inside a function which has been called, which is again very useful functionality. In contrast, a jump allows us to move to a different position in our code to jump to a label, but it doesn't leave a positional flag. It also ignores any code between where we initiate the jump and where we jump to, meaning that we can jump over pieces of code that we don't want to initiate. This is very useful for jumping around within a label if you want multiple possible endings to a label or you just want to skip over certain pieces of code. Once we reach the return label from a jump, we will return to the label in which the jump was initiated from, rather than returning to the position in the code where the call was initiated. That will be demonstrated in more depth momentarily. It is a little bit of a complicated concept to try and explain without demonstrating. So here we are in our Ren'Py code. You can see there's still some bits and pieces left over from the previous tutorial, but you can completely ignore that. This is not relevant within this tutorial. As you can see, we already have a label in our code which Ren'Py generates for us called label start. And this is what's called a special label because Ren'Py specifically looks for the start label to initiate the game once you start a new game. What you can also see at the end of this block of code is the return statement, which tells Ren'Py when this block of code has been completed. Now, as you well know, when we run this code, it simply looks for the start label and begins the game here, and then once it hits return, it knows that the game has ended, so it goes back to the main menu. But what we can actually do here is we can add some other labels, so let's do that right now. I'm going to add a label here, and I'm going to call it test label 01 colon, which tells Ren'Py that the following content needs to be tabbed in. And then what we can do is we can just say, let's say have Barry say this is inside our label, and then we can simply hit return if we can spell return correctly. And what I'm actually going to do is I'm going to put our call statement at the very beginning of this code. And as you can see, the test label 01 that we type here doesn't turn blue. That doesn't matter. We're just telling Ren'Py that this is a variable, or this is a value that it needs to look for. And what's going to happen is that it's going to hit label start, and then immediately it's going to call this label instead, which means that our marker is going to be placed here at the beginning of this statement. We're going to jump or leap over to this label. We're going to carry out the code within it. Once we hit the return statement, we're going to jump back to this statement and carry on with the rest of the code. Now the difference between this and a jump label will become more apparent in a few minutes, but if we just run this code, What you can see once I've hit the start button is it goes to our label first. This is inside our label. Then it jumps back and then it carries out the rest of our code as if nothing had ever happened. Now if we were to change this code to say jump instead and then run our code again, now that we've run our code we can still see this is inside our label, but when we click the mouse button the game ends, and there's a good reason for that. What's happening is that we're putting a jump statement here, so we're jumping to this position here, and Ren'Py is ignoring the fact that there's this code here and this return statement here. So what Ren'Py sees as being our start label now is, if I were to cut that out, now what it's seeing is this. So it's saying label jump start, jump test label there, so it's jumping to here. But it's not seeing itself as being inside a new label. All it's doing is taking this test label 01 as a position within the start label. So we're jumping to that. Ren'Py assumes that this return is now the end of the start block rather than the test label 01 block, and so it ends the code. Now you're probably thinking at this point, well, why is that useful? Well, there's a good reason for that being useful, which we're going to talk about right now. Let's say we want our start block of code to have two different endings. What we can do is we can actually create those. So I'm going to put a label right here. And I'm going to say label ending 01. And then I'm going to put another label just here. Label ending 02. And then we'll give that a return here. And what we can do is, just to make life easier, I'm actually going to copy this code and paste it in here. I'm going to make sure that I spell ending correctly, like so. And then we're going to change the ending of this one to say, hi, I'm Barry. I love toast. And then Sally is going to say, really, I love toast too. Cool. Now we've got these two endings. What we can actually do here is I'm going to introduce you to a new command briefly, but we're going to go into more depth about menus within the next few videos. So I'm going to create a menu here, and I'm going to ask the question, do you like toast? If the answer is yes, then we're going to jump ending 02, and if the answer is no, then we're going to jump ending 01, like so. Now we've got two separate endings to this piece of code, and what's going to happen is if I select yes to do I like toast, it's going to jump straight to ending 02. It's going to carry out the code within that label, then it's going to see a return statement, and because it has ignored all of this code here, it's going to assume that this is the end to our start label, and it will end the code. In contrast, what's going to happen, if I say no, it's going to jump to ending 01, which is this option here, and it's going to carry out this code, and it's going to see this return statement, and then it's going to end the code because it's going to assume that is the end of our start label. Now, remembering to delete the call where we actually selected jump to test label 01 so that we don't get any errors, we're going to run our code now, and we're going to hit start. And as you can see, do you like toast? The choice menu comes up. I'm going to start by saying no, and it's going to say, hi, I'm Barry, how are you? Hi, I'm Sally, doing great, how are you? And then it ends the code. If I run the code again, and this time I select yes, hi, I'm Barry, I love toast. I really love toast too. So as you can see, everything that we discussed has actually happened. And this is a really powerful tool because it enables us to jump around within our code and include things that we maybe want to do. So let's say, for example, I want a function to be called every now and again that adds a value to another value. So let's say, for example, we've got a variable. So I'm going to say x equals 10. And then I'm going to create a label at the bottom of our code here. And I'm going to call it label increment underscore x. And in that code, I'm actually going to say x plus equals 1. Return. Now what I can do is if I was to have a game loop instead of this code here, I could continuously call increment x every time I wanted to add 1 to the value. and it would return back to where it went every time. So in pseudocode, let's presume that we had a loop here. I'm not actually going to run this, I'm just demonstrating it. Let's say we've got for I in range 1, 10. So we're going to say for each going to run through this label 10 times, and then we're going to just add there. Again, this is sort of semi-pseudocode, so it's not going to actually work this way. But what I've done is I've created a range of 1 to 10, and I'm going to say for each one of those, I'm going to call increment x. And what would happen is it would run through and it would call increment x 10 times. So at the end of it, what we'd actually have is x equals 20. Really useful functionality to enable us to create functions that we can call and implement without having to retype the code over and over again. Because if you wanted to do that manually, you'd have to keep typing x plus equals 1, which is less than ideal. So that brings us to the end of this lesson, guys. I hope you found that useful. Let me know what you think in the comments below, and I will see you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.